Now the next is geometric progression. That is GP sequence. As we learnt about till now, AP sequence, AP series, consecutive terms of AP and its problem. Now we will do GP in the same manner. So if the ratio of any term to the preceding term is constant, then the series is called geometric progression. That is GP. Here the constant ratio is called the common ratio and is denoted by R. Or in other words, we can write a sequence f of n to r such that f of n is equal to capital A, capital R raised to power n, and A belongs to, that is R minus 0, that is A is not equal to 0. Sorry, here R is not capital, R is small. Then R belongs to R minus singleton 0, that is R is not equal to 0, is called geometric progression. That is a GP is an always exponential function and an AP is a linear function. Now for n is equal to 1, 2, 3, so on, we get terms of GP as AR, AR square, AR cube and so on. So this is all about the GP, that is geometric progression. Now we are going to state theorem 4 that says that ratio of any two consecutive terms of a GP is a non-zero constant. Now we will prove this theorem. First, f of n to r is a GP. Then we have f of n is equal to ARn for all a is not equal to 0, r is not equal to 0 and n belongs to natural number. Then ratio of two consecutive terms of GPR such that f of k plus 1 and fk. Then ratio f of k plus 1 over f of k is equal to ar raised to power k plus 1 over a into r raised to power k. So we get which is equal to r, which is a non-zero constant. So result of the theorem is proved that a ratio of two consecutive terms of a GP is a non-zero constant. Now the next theorem of GP is, that is theorem 5, which states that if the ratio of two consecutive terms of a sequence is a non-zero constant, then the sequence is a GP. Now the proof is, consider Pn, that is, we will prove this result by principle of mathematical induction. Fn is equal to AR n minus 1, where a comma r belongs to r minus 0, that is a and r are non-zero constant, where a is the first term and r is the common ratio. Now for n is equal to 1, this is the first part, we get f of 1 is equal to a into r raised to power 0, that is a, that is the first term of GP, which is true. Therefore, result is true for n is equal to 1. Now we will assume, let the result be true for n is equal to k, that is f of k is equal to ark for all k belong to n. Now we will prove the result for n is equal to k plus 1. That is, we have to prove f of k plus 1 is equal to ar k plus 1 for all k belongs to n. Now, as we know that ratio of two consecutive terms of a GP is a non-zero constant. Therefore, f of k plus 1 is r times f of k. That gives r times ar k minus 1. That gives a into r raised to power k minus 1 plus 1, that is a into r raised to power k. That can be reformed as a into r raised to power k plus 1 minus 1. That is true. That means if pk is true, that implies pk plus 1 is true. Therefore, by principle of mathematical induction, P of n is true for all n belong to n. Hence, f of n is a GP, that is geometric progression. Therefore, geometric progression is a series with first term A and common ratio R is A, AR, AR square and so on AR n minus 1. So here Tn is AR n minus 1 for all A is not equal to 0 and R is not equal to 0. And if A, B, C are consecutive terms in GP, then B over A is equal to C over B gives B square is equal to AC. That is, B is the under root of product of first and last term. So this was all about the GP series. That is GP progression, that is geometric progression. So in geometric progression we see that A is the first term and R is the common ratio. Then Tn term of a GP is AR n minus 1, where R is the common ratio, that is any two terms, consecutive terms whose ratio will be constant, a non-zero constant. And in AP there is a common difference, we take difference, and in GP we take ratio, but both are constant. So this is all about the geometric progression. Now we will do some problems which are based on GP. Find nth and eighth term of the GP sequence, that is 54, 36, 24, 16 and so on. Now here if we see A is equal to 54 and R is equal to T2 over T1, that is 36 over 54, that is on 18, 18 2s are 36, 18 3s are 54. So the ratio is R is 2 by 3. Here that is given, it is a GP sequence already. Otherwise we have to check it is a GP or not GP. Then its nth term is AR n minus 1, that is 54 into 2 by 3 raised to power n minus 1. So it is its nth term. And we have to find its eighth term, then T8 by substituting 8 in this. 54 into 2 by 3 raised to power 8 minus 1 is 7. So open it. Open to 7 times, 4, 5 times, 6 times, 7 times over open 3 7 times, 5 times, 6 times, 7 times. Now we will cut out by 18. 3 ones are 3 eights are 24. 3 6 are 18. 3 twos are 6. On multiplying, it becomes 2 raised to power 8. It is 256. And here it is 3 threes are 9. 9 threes are 27. 27 threes are 81. So T8 term is 256 over 81. Now the next problem is, if the third term of a GP is 18 and sixth term is 486, find the ninth term. Now we have to find ninth term on the basis of given conditions. Now the solution is, we have T3 is equal to 18 and T6 is equal to 486. As T3 is 18, that means AR 3 minus 1, that is square, is equal to 18, that is number 1, and T6 AR 6 minus 1, that is 5, is equal to 486. This is number 2. Now, in such type of problem, we will divide. So divide second by 1, that gives, that is T6 over T3, that is AR 5 over AR square, that is 486 over 18. So we will get AA cancel out, R raised to 5 into R raised to minus 2 is equal to 486 over 18, it gives 27. So we get R cube, 5 minus 2 is cube. If base are same, powers are going to be add. So we add up these two powers, it becomes 5 minus 2 is equal to 3, which is equal to 27. So we get its cube root of 27 is, its one real root is 3, because it is equal to 3 cube. So its one root is 3, other roots may be complex or irrational roots. Now, as we have AR square is equal to 18, that gives A into 9 is equal to 18. From where we get 18 by 9 is equal to 2. Therefore, we get A is equal to 2 and R is equal to 3. Now we can find any term of the GP series. Now we have to find T9. Therefore, T9 is equal to AR 9 minus 1 is 8, that is 2 into 3 raised to power 8. Multiply 3 8 times and into 2. Then we get 13122. That are the simple calculation. So this is each of the question related to geometric progression.